Howdy folks, welcome back. We are continuing in section 4.4. We're going to look at example 2 now, which wants us to find the cosine of alpha, given that the sine of alpha is equal to 5/13 and alpha is in quadrant 2. So this one, a diagram is always obviously a good thing to do with these, but more importantly is looking at this 5/13 because we can worry about the signs, S-I-G-N-S, of these trig functions after we find out the actual value. We can make it positive or negative as appropriate. So the first thing is try to break down this sine of alpha equals 5/13. So we don't need to draw it in the second quadrant per se. We can just draw any kind of right triangle and then kind of go from there. So if our angle alpha is down here, and we know that the sine is 5/13, we know that should be the opposite over the hypotenuse. So we can say that this is 5 and this is 13. Now if we kind of analyze this, we know hopefully that this is a Pythagorean triple. So 5, 12, 13. But if you're not sure, you can always find this remaining side. So we know that 13 squared equals 5 squared plus b squared, and we can quickly do the math on this one. So if we subtract 25 from both sides, we can get 144, and so that does tell us that our third side is 12. All right, so now that we know that, so how do we apply this to the problem? So, well, first thing is we can get the cosine of our angle based off of this information, but we still don't know about if it's going to be positive or negative. So we'll talk about that in a second. So the first thing is just to realize that the cosine of alpha has to be the adjacent over the hypotenuse, so 12 over 13, but is it positive or negative? So remember our little cheat sheet from before. So sine is positive, cosine is positive, sine is positive, but cosine is negative. Again, remember cosine deals with the values of x, sine deals with the values of y. So we know that x's are negative on this side of the y-axis. So this should be a negative 12/13. And that's it. So that one is done. Let's take a look at one more, and this will be a fairly short video. So the terminal side of theta lies on the given line in the specified quadrant. Find the exact values of the 6 trigonometric functions of theta by finding a point on the line. So we have the line 2x minus y equals 0, and we're in quadrant 2 again. So now the one thing we should probably do is just rewrite this in the appropriate format. So if we solve this for y, we're going to get y equals 2x. Now, if we drew this, so we have a y-intercept of 0 and the slope is 2. So we should be looking at something like this. Now, you might be saying, well, wait a minute, something's wrong here. And you'd be right, because the quadrant they're looking at for our angle is quadrant 2, and our terminal side can't possibly be in quadrant 2. So in order to accommodate that, let's just make a little change and say that this is quadrant 3. So if we now said we're in quadrant 3, that puts us down into this quadrant here. So our angle would look something like this. So that should be our angle theta. All right, so now we have a picture that aligns with the line that they provided. So we should be able to go from here. Now, if you wanted to find a point on this line that was in this third quadrant, well, what would that point be? Now we know that we'd have to go over 1 and up 2 to get a point in the first quadrant, so we can go the opposite direction and get a point down here. So the coordinates of this point should be -1, -2. So now that we have that ordered pair, we should be good to go. Now remember, the first thing we need is the third side, which in this case is r. So remember, r is equal to the square root of x squared plus y squared, and so we can quickly plug in our values of -1 and -2. So we get 1 plus 4, which is the square root of 5. So now we have r, so we should be good to go. So we want to find all 6 trigonometric functions, so it's just a plug and chug from here. So let's start with sine. So sine, remember, is y over r, so y is -2, r is square root of 5, so we got -2 over the square root of 5, and let's rationalize the denominator. So -2 square root of 5 over 5. Cosine should be x over r, so -1 over square root of 5. And same thing, let's rationalize that. And then we got tangent. So tangent, remember, is y over x. So y over x, so -2 over -1, which is +2. And then we can finish off the rest of them pretty quickly. So we can just flip over this unrationalized one. So we get negative square root of 5 over 2. Secant will be the reciprocal of that, which we can see would be negative square root of 5. And then cotangent will be the reciprocal of that, which should be 1/2. And that is it. So again, we can do these problems pretty quickly as long as we have all 3 variables. So, obviously a drawing that aligns with what the quadrant should be is important, and we can also look at problems of this nature up here, which doesn't necessarily need x, y, and r, but more of a right triangle analogy, and then just realizing the right quadrant that it has to fall in. So, all right, well, let's stop there, and then we'll pick up more applications in the next video. See you soon.